Okay, this is going to be on solutions. We already talked about solutions earlier in the year. And there's the definition: two or more substances uniformly spread throughout. So I always talk about solutions if you had, if you took two handfuls of the substance and you looked at each, they would be identical and they have the same properties. Okay, so yeah, we're going to talk about solutions here. First off, dissolving. So a typical dissolving process would be salt in water. Okay, salt water. And so the salt is known as your solute. The solvent is known as the water. So whatever is being dissolved would be the solute. Whatever is doing the dissolving would be the solvent. If you ever heard where divers come up too fast if they're in the water very deep, when they go down, nitrogen dissolves in the bloodstream. Okay, nitrogen in that case would be your solute. The bloodstream would be your solvent. Okay, I bring that up because whenever we have solutions, we always think of like a solid and a liquid, but that doesn't have to be the case when we're talking about this. Okay, so everybody should know what dissolving is. Now, solubility, I started already one before this, but it talks about how much of the solute will dissolve in 100 grams of the solvent. Right here, many times in class, pretty much all the time, we would just use water as a solvent, okay? So when we use 100 grams of water, that's just 100 milliliters. So if you could picture what a 100 milliliter graduated cylinder would look like, it's hard to tell, but maybe about yay big, right? Maybe about so big around. That'd be 100 milliliters of water. Now, there's some things that do affect the solubility, for example, the pressure, the temperature. In this case, we're going to talk about temperature, okay? So let's say in water, we have something here, and we start putting it in, okay, in the water, and it dissolves and it spreads throughout. We can't really see it anymore at all. And then you keep putting more in, and all of a sudden you start to see it form along the bottom. Okay, that means that the water would be holding the maximum amount of solute. When I say holding, I mean dissolving. Okay, now, we have this like thick layer of junk on the bottom that didn't dissolve, okay? If we increase the temperature and you kept stirring this, you would notice that some of this would go away because it would be starting to dissolve into the water. That's what this says right here. Higher the temperature, the more it will dissolve, higher solubility. So to me, these are a little out of order, sort of, because I would always do unsaturated first. So let's just make up a situation here. Let's say that a maximum amount of solute is 5 grams in 100 grams of solvent. So if we had 100 grams of solvent, whatever it is, water is fine, and we put 1 gram in, it would all dissolve. We would call that unsaturated. Okay, it's less than the maximum. We're going to call this right here our maximum. 5 grams. So let's say if 1, it stirs in. 2, 3, 4, it all stirs in. When you hit 5, we call that saturated because no more than 5 can actually dissolve. Okay. All right. So a lot of times you can look these up in tables in books, like how much salt can dissolve in 100 grams of water, how much, like if a chemical can dissolve in 100 grams of water, and you can look those things up in a book, okay? Now, once in a while, you'll get this special situation here. And there's different ways to do it. If anybody's ever grown crystals, like sugar crystals you get like a jar, and you put like sugar water in, and then you put like a paper clip along the top, or you put like something along top of a pencil with a string with a paper clip hanging in, and it forms salt crystals. You're sort of getting this super saturated solution situation. So somehow, some way, it actually ends up holding more in the solvent than you would think. So let's say we were to put 6 grams in, and it all dissolves. There's none sitting at the bottom. You would be like, wow, that's a super saturated solution. Now, one way that you can do that would be to go back to the last slide. If you raise the temperature of this up, okay, and this all dissolves off the bottom, let's say the extra stuff, okay, and then you let it cool down, sometimes that situation will lead to more solute being in here. Okay? Say it one more time. So let's say we put 5 in here, then we put 6. Okay? And it's sitting along the bottom in 100 milliliters of water. We heat it up. This on the bottom dissolves. So now 6 grams of the substance is all dissolved, even though only 5 should. We call that, well, that wouldn't be supersaturated yet, okay? Because as temperature goes up, solubility goes up. If you let the temperature go down, there is a chance that all 6 will stay suspended, okay? Or they will stay dissolved in the water, okay? And we would call that a supersaturated solution. Oh, it even says it right there. Sometimes I don't read what it says underneath before I start talking about it. And the interesting thing about that would be, like, let's say it happened to be sugar, okay? So you reach a supersaturated solution of sugar. If you take just a little tiny speck of sugar at that situation, you toss it in, all the extra stuff should fall out to the bottom. So whatever was supersaturated, whatever extra amount it was being held, it would fall to the bottom if you disturb it. Okay. If anybody's ever seen those videos where they take a bottle of water and they put it in a freezer and they bring it out, but it's still water, and then they go like, and they hit it, and it turns to ice like instantly. It's sort of like a similar kind of example, okay? Because it should be ice. It wasn't. And when it was disturbed, all of a sudden it does what it was supposed to do. All right. So here's a little picture down here. Unsaturated solution, more solute dissolves, so you could keep putting more and more in. Saturated solution, no more dissolves. You could see it forming on the bottom. Supersaturated solution, added crystals grow. So in a supersaturated solution, like I said about the paper clip hanging off a string and making sugar crystals, those extra sugar crystals would probably start to form on the paper clip or whatever was hanging down. Okay. All right. Concentration. So here's your concentration examples here, and I'll do these in a different video. It's a measured amount of solute in a given amount of solvent or solution, okay? So we tend to use words like concentrated and diluted, pretty much everyday kind of words. Concentrated means there's a lot of stuff in it. Diluted means there's less, okay? And we do this by a percentage, okay? And you see there's 2 different kinds, by volume, by mass, and we'll get to that later. I'll show those calculations in a different example. All right. Or a different video. All right. So here we go. When you dissolve, how do you increase the rate? Okay. Pretty simple stuff if you think about it. 1, increase the temperature. If you increase the temperature of anything, whatever you're talking about, whatever your solute is, will dissolve faster, okay? Also, like let's say we take salt, and you have big clumps of salt, and you put it in water, versus if we grind it all up, and it's little tiny specks, that would be increasing the surface area, okay? So crushing something up so it's a fine powder. And then also you just shake it or agitate it, or we would stir it in class. We don't let it just sit there, okay? Now, I like this one down here, dissolving. Likes dissolve likes. So how will you know that something will dissolve something else? If they are the same type of substance, they'll dissolve. For example, polar or ionic, okay, will only dissolve charged solutes. Why? Because when you have a polar, on one end it's positive, on the other end, let's say it's slightly negative. Okay, and the same thing with ionic. You'd have like a positive side and a negative side. So those would dissolve things that are also charged. Okay. So one time in a class, I stood up on a table and I put a blue pen across my pants. Okay. Now the fact is the blue pen was not water soluble. Okay. And if you recall, water is polar. So our blue pen was not polar. So I took water and tried to get it off. And student's like, you just ruined the pants. And I said, no. And so I found, so the blue ink must have been non-polar. So I believe I used isopropyl alcohol, and it started to take the blue off the pants because it was also non-polar. So that's the example I always give with that likes dissolve likes. So here we go, non-polar will dissolve non-polar things, okay? Now this down here, read that, write it down, okay? Ethanol, one end is polar, the other end is non-polar. We're not going to go into actually drawing what ethanol looks like, but it's just good to know that, okay? So polar and ionic will dissolve charged things, and polar, non-polar will only dissolve non-polar things. Oh, here we go. When a polar substance, it will cause dissociation, okay? So one of the things that we use water for and we use dissolving for a lot is to actually, like, if you ever do a chemical reaction, you'll notice a lot of the times we use things that are already in solutions. So they'd be stuff that's already dissolved in water. The water doesn't actually play an important part in the chemical reaction that will take place, but what it does is it allows the ions to separate, okay? It allows them to separate, and then they may do like a double displacement or a single displacement reaction and form new things. Okay. We also, I mostly in class will talk about dissociation. Ionization. You notice we're talking about polar covalent compounds. They're pulled apart by H2O. For example, HCl, that's hydrochloric acid. The H2O pulled apart, and it'll form like a hydronium ion and whatnot. Okay, but just know the definition. And then used to just dissolve. Okay, no ions formed or released, they just surround it by water. So, for example, a substance, it would not break apart at all. It's just used, water is just used as a way to get it like suspended and flowing. Okay, ions in solution, we call them electrolytes. This is one of my favorite parts. I always preface it with a don't try it at home kind of thing. Okay, but if you ever heard, like, if you're in the bath and don't drop a toaster in there, we used to say, you guys have phones now, everything, but don't put a radio on the side of a bathtub. If it falls in, you get electrocuted. Okay, that's because of electrolytes. Electrolytes allow electricity to be conducted. For example, salt. Salt breaks up into Na and Cl. Okay, when those ions are present, that'd be an electrolyte, electricity will flow. Okay, so I don't know if I have, here, I'll do it this way. And then there's a non-electrolytes. Okay, electricity would not flow. So these are cool things that you could actually look up. This is basically a beaker here. It has two conductors in it, okay, with electricity attached to one end. Goes down, there's a separation between them. And then the wire comes out to the light bulb and comes around. The light bulb will only turn on if this is an electrolyte. So technically, if you're in a bathtub of perfect deionized water, okay, no ions in it, no extra anything, just pure H2O, electricity would not conduct through the bathtub water. Now that's basically impossible, okay? In a small situation like this, where we can pour in deionized water, we call it, or I can't think of it right now. What's deionized water called? Amanda, in a bottle.
What?
What's water called in a bottle that's no ions?
Neutral?
No. I can't think of it right now.
I have no idea.
No, I'll look it up. I mean, it's a very simple term. We use it. It's what you would probably refer to it as. But anyway, deionized. This is going to get long if I keep trying to think. Okay? So one of the tests, if you're able to do this, you can get deionized water, put it in here. You'd see the bulb not turn on. okay, as electricity did not flow. This would be like the barrier, wouldn't flow through. And then take like a little bit of salt, pour it in. You notice the bulb kind of, no. You notice the bulb turn on. And then if you pour more and more and more salt in, the bulb would finally be as bright as possible because you would be conducting electricity through the water. Okay. Oh, we're almost at the end here. Okay. So, we know if you put salt on icy roads, it dissolves, or it will melt the snow, melt the ice or the snow. Okay, depending on the temperature. If the temperature is not too low. So, what are some effects of solid solutes on liquid solvents? For example, salt in water extends the liquid phase. So, what we're saying is this: water freezes at 0, boils at 100 degrees Celsius, right? If you put salt in that, those get wider. So let's say it would freeze at -5 and boil at 105 or something like that, depending on how much salt you have, okay? So it lowers the freezing point, lowers here, and raises the boiling point. Okay? And so lastly, talking about road salt or rock salt, all right? So a lot of times that doesn't make sense to students. Wait a second, if you talk about lowering the freezing point, wouldn't that just make things colder? And I know that's sort of what it sounds like in your head, but let's say it drops to, the freezing point drops to -15 degrees Celsius, okay, which would be kind of ridiculous, but that's okay. Let's just say. Well, that means that if it's -5 out, it'd still be water, okay? So it's just easier to look at maybe putting some numbers. All right. An old activity I did at another school is we would take, we'd boil water and put under a little fire here. Actually, it was just a burner, like an electric stove. And we'd boil the water, and we'd toss like 5 grams of salt in. 5 grams of salt in. Now, the bad thing was it boiled over, and again, it ended up rusting out our burner. But you could actually see, we'd have a thermometer in there, and you could actually see the temperature on the thermometer. It'd be 100 degrees Celsius the entire time while it was boiling, because it was just boiling the water. It would stay at 100. That's a whole other story. Throw the 5 grams in, this would go up. Throw another 5 grams in, this would go up. And you would actually see the temperature increase, which was kind of slick. All right, so that's the notes on, what do we got here? Solutions. And really, it's about solvents and solutes, right? Dissolving and solubility.